Kafka is designed to be fast and scalable. It's not assumed that one only broker can completely handle a topic. That's for three main reasons.
Number 1. If the broker may fail, that topic will be gone. Number 2. It may be too much data in the topic and it may fill the disk. And number 3. It may be that too many producers or consumers and one machine cannot handle the I/O because the clients may overload the server. So the solution adopted by Kafka to solve these problems is the partitioning. Apache Kafka uses partitions to increase throughput and spread the load of messages to all brokers composing the cluster. So being a bit more technical, Kafka divides the topic into partitions, and each partition contains a subset of messages in an unchangeable sequence. In fact, the data in the topics is unchangeable. When you create a topic, you have to specify the number of partitions of that topic. You have to specify also a few other parameters, like the replication factor, but we'll see that in the next videos. The number of partitions identifies the maximum parallelism we can achieve with that topic, and the keys can be used for partitioning your data. When the producer sends messages into a topic, it uses an algorithm to make a decision about which partition to send it to. By default, it attaches the key of the message to a partition. But that can be replaced at producer level by developing a custom partitioning class if you want to partition the data, for example, using a different algorithm. As we can see, the partitioning is a very important concept, and it's what in Kafka does the message ordering.